So this is 10.3, and it's just more about graphing. It gets into specifics about where the line crosses the axes. So if you remember, this is the x-axis, and this line is the y-axis. Here, let me color them different. So the purple will be the y. And if you're going to graph this equation that I have right here, you could make an x and a y table, and you could plug some points in. Maybe you plug, 6 in. So we talked about that last section. So it would be y equals -2 times 6 plus 4. And so that would be -12 plus 4 would be -8. And so I could go over 6, 2, 3, 4, 5, 6, and down 8, 1, 2, 3, 4, 5, 6, 7, 8. And this point right here, if I extended the line would go through that. So this section is specifically about where a line crosses the x and y, and what about if the line isn't slanted? What if it was horizontal or vertical? So those are the things you're looking to learn over this section. So one of the things that they talk about on equations is like where they cross axes. So this point right here is 0, 4, and that's called the y-intercept. It's a really important, the x and y intercepts are really important when you start talking about real life applications to graphs. And so you'll be asked in this section to name the x and y intercept from a graph, from a table, and from an equation. Remember, there's those there's 4 ways to represent this type of linear algebra. It's a graph, an equation, a table, and a story. And so this point right here is called the y-intercept. It's called the y-intercept because if you think about the word intercept, I always think about football. If you intercept a ball, then you're stopping it through going through its pathway. Okay, so this point right here is where the line hits the y-axis. Remember, the y-axis is in purple. Okay, at that point, it's always an x and a y ordered pair or coordinate, and the x will always be 0. The y will be wherever it crosses. So in this case, it was 4. But think about if the line, let me draw it on here for a second. What about if the line went right here? Then the y-intercept, the ordered pairs, would be 0, -2. So no matter where the line hits the y-axis, the x-coordinate, will always be 0. That's an important point that I want to make right now because it becomes really important later on, okay, in finding those. So we've got the y-intercept down. Well, what about the x-intercept? Well, the x-axis is the red line, the red horizontal line, and you can see that the line intercepts it right here at this point. This point, if I wrote it in ordered pairs, would be 2, 0. So think about this. This is your x and this is your y. So again, now you've got a 0, but it's in the y position because it's hitting the x-axis. You want to really make sense of this and try not to memorize it. You want to make sense of, okay, it's there because of that. And if you get confused, if you're like, I don't know which one's 0 when it hits a y, graph something. Graph a line and then ask yourself, what are those points? And that'll help you. So now you know the x and y intercept. There's ways of finding it without the graph. Through the graph is really easy because you can just look for those points where it intercepts, the black points that I circled. So you can just look for this point and name the ordered pairs. But when you're looking maybe at like a table, let's take a look at a table for a second. How would you find it if you didn't have the graph? So now the graph disappears, and now all you have is a table. Well, think about what we just learned on the graph. Think about this point right here for a second. Okay, when it hits the y-intercept, we said the x was always 0. So that means if I put a 0 in for x, and I solve the equation, I should be able to find where it hits that. So that's going to be 4. So this must be the y-intercept. I could do it without the picture. How do you find the x-intercept without the picture? Okay, so let's look at the x-intercept for a second. So here, down here, we were talking about the x-intercept. What's always 0 when it hits the x? The y is always 0. So what if we put a 0 in for the y and went backwards? Okay, so I'm going to write the equation, but instead of putting the 0 where the x was, I'm going to put it where the y was. So the y was first, and it was y equals negative 2 times x plus 4. And now if I'm going to solve for x, I can take my 4 and move it over. And divide by negative 2. And I get x equals positive 2. If you're not sure, if you're struggling with this part of the algebra and you're like, man, I always make mistakes, I never know if it's negative or positive, plug it back in and see if it really does make 0. Like, what I mean is take this 2 and put it in where the x is, and then just use your calculator. Negative 2 times 2 plus 4. Does it really equal 0? If it does, then you know for sure. That's what's nice about algebra. As soon as you learn that you can plug stuff in and double check it, you don't need to know if you're right or wrong. If you understand the way that the equations work, it makes everything so much easier. And so let's say all this equation or all this graph was gone, you could still find the x and y intercepts, and this is the x-intercept, through a table. So what about if the table was gone and the graph's gone, and all you have is this equation? You could make a table, right? You could sit there and make a table. You could go, okay, well, I'll just go from the table. Or you could graph it, look for the graph. The book shows you something too. Let me rewrite this. And if you don't quite get this, that's fine. If it helps you, that's great too. There's this equation that I'm writing right now. When it says y equals, that's called a slope-intercept. If I pull the x value over, I get 2x plus y equals 4. This is called a standard equation. And the book talks about it being ax plus by equals c. Okay? The standard equation is useful for finding x and y intercepts fast. Let me show you what I mean. If you understand the whole point about what value is 0 when it hits, like let's say, let's think about the y-intercept again. So let's say a line comes through like this. Right here, which value is 0, the x or the y? Remember, you don't want to memorize it, you want to make sense of it. So you should have said the x. So I know that it's 0 and something. Okay? Well, if x is 0, I can put a 0 in right here, and it's a little bit quicker than trying to do what I just showed you earlier about putting a 0 in, because you don't have to do any inverse operations or moving things from right to left. If I put a 0 in there, 2 times 0 is 0, I get y equals 4. So right away I know that the ordered pair is y and 4. Oh, I just wrote that like it was a table. Is 0 and 4, sorry. Okay, I could reverse and do the same thing for the x-intercept. I know that the y will be 0. So I know it'll be 2x equals 4. Well, think about that. 2 times what equals 4? 2. So I know that it's 2, 0. Okay? When I spend a lot more time on this in class, we call it the cover method, because if you won't be able to see this really on this screen, but I take my finger and I cover this and I ask them to solve, and they go y is 4. So the y-intercept is 4. So then I take my finger and I cover this one and I ask them to solve, and I say, what's x? And they say the x is 2. So we call it the cover method, and they can find x and y intercepts easy. If you are going, I don't like that method, I mean, you can read inside the book. I think it was on page 67 or something. But you can always just do it the other way, too, that I was explaining. It's all about, can you find the intercept? And there's no reason why, if they ask you to find an x and y intercept from a table, there's nothing that says you can't graph it real quick, or you can't, if they say find it from the equation, there's no reason why you can't quickly, draw a table and do it that way. It really doesn't matter. As long as you can find x and y intercepts from the equation, the table, and the graph. So why are x and y intercepts important? They're most important for, right now, for story problems. And remember, I'm not going to do a ton of story problems on these type of things, so make sure that you, take the ones in the textbook seriously, and any ones I put on reviews or quizzes or anything like that, make sure you go back through them, because there'll definitely be story problems on the final. Let's just say that this is the graph, and this is actually on page 67, so you can look at it if you want. So the y-axis is the distance from home. The x-axis is the time in hours. And so if I asked you, what's the x and y intercept, and what's the importance of it? Okay, so y-intercept. What is the y-intercept in this story? And I'm just giving you a second so you can think ahead of me. So you should have said, well, the y-intercept is 200. Okay, you can also say it in an ordered pair. So x is 0, y is 200. Also, on the final, make sure if they tell you ordered pair that you put it like that, because they are marking students down for that. Okay, so what's the importance of it? Well, if this is the distance from home, what did 200 mean? 200 meant that's how far he was from home when he started. Okay, so this point right here means that that's what happened at 0 hours. So we had to have been 200 miles from home before he even began to come home. Okay, so what is the x-intercept? So if I asked you what the x-intercept is, what would you say? And you should say 4, or the ordered pair, 4, 0. Okay, what does that mean? That means it took him 4 hours to get home. I can guarantee you they will have questions, and I will have questions and quizzes about what the intercepts mean. That's very important, to be able to read a graph and say not only what the intercepts are, but what's the meaning of them. Okay, so now let's see if you kind of can pull this all together. So I wrote a table, a graph, and an equation, and they are not related in any way. It's not the same equation all the way through, the same line all the way through. So they're 3 separate problems. If I asked you to name the x and y intercepts on the table, I want you to pause it. Or actually, if I asked you to name on all 3 of these, I want you to pause it, and I want you to write down the ordered pairs, so the coordinates, of the x and y intercept for each problem. So remember, these are 3 separate problems. Okay, so pause it, and then when you come back, I will run you through it and see if you're right. Okay, so let me change colors. In the table, you can see that the x was -1 and the y was 0. And right here, the x is 0 and the y is -1. Now, if you forget which is which, that's always the case, I think, as people go, I can't remember which is x and which is the y, which one's supposed to be 0 and when. Graph it. -1, 0, plus if you graph it every time, then you'll get better at graphing. One of the things that I asked some of the instructors that teach this course, they said, where do the students fall apart at? And they said the graphing part, that a lot of them just can't graph, and so, or accurately. So x is -1, y is 0 is right here. And so that means that must be the x-intercept. So I can write x-intercept is -1, 0. and 0, 1 is right here. Oh, my pen won't work. So that's the y-intercept. I guess I always think about it when I'm finding the y-intercept, it's always, I always want to put a 0 where the y value is, but it's always backwards. So I always have to remember it's backwards of what I think it will be. And sometimes I sit there and draw it because I will look at the 0 and the 1 and it's like, okay, which is in which? So, you know, feel free to draw it if you have to. There's nothing wrong with that. You know, drawing it takes you 1 extra minute. You can afford it, you know, if you're trying to figure out which is which. So on the graph, that's the easy one, I think. So here's the x-intercept. So y is 0, whoops. And see, I just did it wrong as I told you about it. Man, if you had dyslexia, this would be really tough. So -2, 0. This is x, this is the y. You know, labeling stuff will always help you too, you know. The more careful you are there, the better. I mean, if you're on the final and you get the x and y mixed up, they will take probably all 5 points off of you. So labeling it and then getting it wrong, they would see that you had it labeled right, you know, and then got it wrong. They might, you know, give you some points. So this is the x-intercept. This one is the y-intercept. And that's 0, -2. And I just noticed that on both of these equations, I made the x and y's to have a -2 and a 0 and then a 0, -2. That doesn't always have to happen. That's just the way I made the line. Okay, so then the equation, I'm going to choose the method of putting a 0 in for the x. And I know if I put a 0 in for the x, then it gives me the y-intercept. So if I think of that as 0, then I get 2 times 0 is 0. And then I get 7y equals 10. So if I divide by 7, I get y equals 10 sevenths. And I'm just going to leave it as 10 sevenths. So the y-intercept is 0 and 10 over 7. You can leave it that way. Okay, now I'm going to do the x-intercept. And so I'm going to put a 0 in for the y. So that's going to be 0, and I'm going to get 2x equals 10, running out of room here. Divide by 2, and I get 5. So I know I get 5, 0 for the x-intercept. Okay, so see how you did on that. See if you did okay. Okay, there's one on the homework that's a little bit tricky, so I'm just going to toss a similar one on here to kind of help you through that. So they had an equation like this. Now remember, if the fractions freak you out, just pretend like there's nothing there for a second and say, what would I do to find the x-intercept? Well, I would put a 0 where the y is to find the x. And so then go ahead and do that. So say, okay, well, then that would be -x over 2 plus 0 over 5 equals 10. 0 over 5 is 0, so that's gone. So I get -x over 2 equals 10. Okay, so if you're not sure how to solve this, if you're like, well, where's the negative go? Is it on the x or is it on the 2? When you have a negative on a fraction, it can be wherever you want. So I'm going to put it on the 2 because it's going to be easier for me to think about multiplying both sides by -2. Okay, I can also think about this. What divided by -2 is 10. -2 goes into what 10 times? Well, that would be -20. And I could try it on my calculator. So I get -20. So I know that the x-intercept is the ordered pair, -20, 0. Now to do the y-intercept, I'm going to have to put a 0 in where the x is. And there's no such thing as a -0, but I'll put a negative out there. So again, real quick to reiterate on that, if you have a fraction, so like say it's -x over 2, that's the same as saying x over -2, and it's also the same as saying -x over 2. So it doesn't matter if the negative's on the numerator, the denominator, or out front. So you can move it wherever you want, but there's just one negative. Okay? That's like a common misconception. So back to this problem. So this is 0. I get y divided by 5 equals 10. So what divided by 5 equals 10? Well, it's got to be big. It's got to be 10 times bigger, so it's got to be 50. If you can't reason it out that way, remember, you can multiply by 5 on each side. Y equals 50. Sometimes people get into doing the order of operations, or they go, I don't know if I'm supposed to multiply or divide by 5. Well, just think about what this number should be. Something divided by 5 equals 10. Okay, so the y-intercept is 0, 50. Okay, so the second part of the assignment talked about horizontal and vertical lines. Okay, so if I make a horizontal line, I'm just going to make it right here. And I wanted to know what's the equation to that line. Well, let's look at the ordered pairs that make that line. Let's randomly put some dots on the line. And let's write down what they look like on a table. Okay, so this ordered pair right here is 3, 0, or wait, 3, 3. Nice if I could do it right. Okay, so I know I've got 3, 3 as an ordered pair. This one right here is 2, 3. This one right here is 1, 3. Noticing a pattern? This one right here is 0, 3. This right here is negative 1, 3. So look at how all the y's were 3. So the equation to a horizontal line will always have all the same y's. What does y always equal in this case? 3. So the equation is y equals 3. Your equation won't have an x in it if it's a horizontal line. Because the x's are always changing, it's a y that stays constant. Then the reverse of this is what happens if you have, and I'm just going to put it over here, a horizontal line. Well, let's put some points on the horizontal line and look at it as a table. So 1, 2, 3, 4, 5. So that's going to be 5, 0. This one's 5, 0. This one's 5, 1. This one's 5, negative 1. This one's 5, negative 2. Are you seeing a pattern? So in a vertical line, what is always constant? X. What is x? X is always 5. So a vertical line will have an equation that doesn't have a y in it. These, again, it's one of those things you don't want to memorize. You want to get it straight in your head, and you want to have some method if you get confused. I'm telling you, I sometimes will stop and go, okay, horizontal line, is that an x equals or a y equals? Vertical line, is that an x equals or a y equals? And sometimes I will physically stop and draw the line and make the table. So that's why I'm showing you how to make the table, because if you forget, then you can always go to drawing a line, making a table, and go, oh yeah, it's x equals 3, because x always, or y equals 3, or x equals 5. Okay, so to sum that up, and remember on skills checks, try not to use your notes, because you're checking to see if you truly understand it. So let's sum this up. So if I randomly draw a line right here, it's a horizontal line. Is that a y equals or an x equals? Okay, you should have said it's a x equals. And this one would be 1, 2, 3, 4, 5. Oh, I drew the same one as last time. X equals 5. Okay, if I draw a line right here, this one's a vertical line. 2, 3, 4, 5. So this is a y equals negative 5. So you try it. You name the equation. So after I draw it, pause it and name the equation. So here's x and y axes. And I'll draw a purple one. So name the equation that goes with that purple line. And then when you get done, name the equation that goes with the green line. Okay, then when you come back, then I will put the answers on there. Okay, so there's your two answers. I always try to remember it too, if it crosses the y-axis, it's a y equals line. And these are the ones where you go, oh, well, it runs the same way as the x-axis, it must be an x equals. No, it's always opposite of what you think. So like a horizontal line runs the same way as x-axis, but notice it's not an x equals line. It crosses the y-axis at 8, so it's a y equals line. You know, put it on note cards and test yourself, because these are the things you don't want to try to memorize. You want to make sure that you get it in your head pretty stable. So getting a little bit harder, can you give me an equation? So I want you to write me the equation of a line that passes through, let's make it a horizontal line. Horizontal line that passes through the point 0, no, let's not go 0. That passes through the point 3, 7. So give me the equation of the line that passes through that point and is horizontal. Okay, so you should have said y equals 7. If you're like, well, I don't know that I would have got that. I don't know if I should have said y equals 3, x equals 3, y equals 7, what? Then graph it real quick. Go, okay, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So the point would be here. I said horizontal. So if you still were confused, you could put some more points on that horizontal line, make your table, and go, okay, well, when x is 3, y is 7. When x is 4, y is 7. When x is 5, y is 7. And then you'd remember, oh yeah, y equals 7. So they'll ask you questions like that too. They'll say, well, give me the equation of a line that's horizontal that passes through this, or vertical that passes through this. Okay, so if I asked you for a vertical line, I changed this, and I said, what if I asked you for a vertical line that passed through 3, 7? Then you'd say x equals 3. Okay, one last stab at story problems. So let me ask you this. So let's say this is the money in your account for the month. Did I just spell account wrong? Oh, money in your bank. There we go. And this is the days of the month. Okay, and let's say the graph looked like this. Okay, so this is, it starts at 110 and it comes down and it hits 30. If I asked you, name the, I want you to pause this and I want you to name the x and y intercepts and say what they're, what they mean. Interpret them. Okay, so the y-intercept is 0 and 110. It's the amount in the account at the start of the month. And then the x-intercept is 30, and it's the day that you have no more money in your bank. So that's pretty much 10-3.